All right, so today we're going to start verifying trig identities. And so here are the guidelines. So your job is to prove that one side of the identity is equal to the other. So you will only work on one side of the identity. And you always want to work on the more complicated side and try to transform it to the simpler side. More complicated can mean the side is longer or has more complicated expressions. And typically, additions or subtractions are more complicated than multiplications. All right, if an expression can be multiplied out, do so. If an expression can be factored, do so. If you have a polynomial over a single term, you can split it into several fractions, and I will show you how to do that. We haven't done that yet. I'll show you how to do that today. All right, if you have an expression that involves adding fractions, do so by finding a common denominator, which we've done. And then 7, when in doubt, convert everything to sines and cosines. This is typically more helpful when you have multiplication or division. Okay. 8, don't be afraid to create complex fractions. So a complex fraction is a fraction within a fraction, which a lot of you don't like. So we've done this some already. So you've had cosine over tangent, and then you decided to do cosine of x over sine of x, cosine of x. That is a complex fraction, and then you're going to multiply by the denominator, and you don't like it, but typically then you are just one step away from the solution once you get it to a complex fraction. All right, and 9 is my favorite. Always try something. You don't have to see the solution before you actually do the problem. Sometimes when you try something, the solution just evolves. All right, so always try something. So you're going to need your own paper, and this is going to be lesson 5.2, verifying trig identities. All right, so for example 1, our directions are to verify. For A, we have cosine squared of beta minus sine squared of beta is equal to 1 minus 2 sine squared of beta. So this is one where it's not super obvious which one is more complicated because they both have two terms. They both have subtraction. But when I look at it, I think that cosine squared is more complicated than just a 1. So our more complicated side is going to be the left side. So we want to change the left to look like the right, and we're going to use our identities. So when I look at it, I see that I want to end up with 2 sine squared of beta. So I would choose to leave my sine squared of beta alone because I know I want sine squared in my answer. And I would change cosine squared of beta, keeping in mind what I want to end up with. Okay, so you would look at your identities and try to see if there's a way that we can change cosine squared of beta to something that involves sine squared, because sine squared is what we want to end up with. All right, and if you look down at Pythagorean identities and kind of manipulate them a little bit, cosine squared of beta is 1 minus sine squared of beta. Okay. And then we would want to combine our like terms. So negative sine squared of beta minus another sine squared of beta gives you negative 2 sine squared of beta. And then we're done. We have made the left side look like the right side, and you're finished. All right. Now, this is something you definitely cannot skip steps. You need to show me everything. This is like what I've talked about before. You're writing a paper. You can't just write the first and last sentence or even the first and last paragraph. You have to write the whole paper. All right, so on B, we have a fraction. The numerator is sine of x plus cosecant of y, and the denominator is sine of x times cosecant of y. Now, we cannot change our variables here. We're going to leave them just like they are. And this is one that we are going to split the fractions. So something we haven't done yet. So this is like a polynomial. We have addition or subtraction in the numerator and a single term in the denominator. So addition or subtraction in the numerator, no addition or subtraction in the denominator. We are going to split this fraction. Sorry, I didn't finish it. So that should equal sine of y plus cosecant of x. Okay, so because I have multiple terms in the numerator, a single term in the denominator, I'm going to divide the fraction where I'll put sine of x over the whole denominator, and then I'll put cosecant of y over the whole denominator. And this is perfectly acceptable to do because if I added those, it would give me back what I started with. So they are congruent statements. We can separate the fraction like that. Okay, now within each fraction, there is no addition or subtraction. So I can just reduce that by sine, and that by sine of x, and the other one by cosecant of y. And then don't forget, when everything cancels out of the numerator, you're left with a 1. All right, and then 1 over cosecant of y is a reciprocal identity. That's just sine of y. 1 over sine of x is a reciprocal identity. That is just cosecant of x. And that is what we wanted to end up with. Okay, so one more. For C, we have multiplication. We have in parentheses 1 plus cotangent squared of x. And then in another set, we have 1 minus sine squared of x. Now, I do know, sorry, that should equal cotangent squared of x. I do know that it's hard for you to know when you need to multiply, when you need to simplify, or when you need to do lots of different things. There's possibilities here. I would typically say that when you notice that you have 1 plus a squared trig ratio or 1 minus a squared trig ratio, go ahead and look at your Pythagorean identities. Now, it might lead you down the wrong path, and then you might have to go back and try something else, but typically that's going to help you. So 1 plus cotangent squared of x is an exact identity that is going to give you cosecant squared of x. All right, and then we're going to multiply that. Another Pythagorean identity that's manipulated, 1 minus sine squared of x is going to give you cosine squared of x. All right, then we'll just bring down our cotangent squared. All right. So this is one of those situations where we want to convert everything to sines and cosines because we're multiplying. We want to end up with cotangent, so we want to write everything using sines and cosines. So cosecant squared is the same as 1 over sine squared of x. Now cosine is already a cosine. Then when I multiply that together, I multiply across the numerator, across the denominator, so it's over 1. Right? And then that's an identity. That's our quotient identity. That's going to give you cotangent squared of x equals cotangent squared of x. And you're done. All right, so we've learned most of all the little parts that you need. The only new thing we did today was split the fractions. Everything else we've we've been doing the last week. And so you just get to apply them to verify. And you may have to use multiple techniques in one problem, but you can do it. So your assignment is a worksheet. You definitely don't have enough room to do it on the little half sheet that I gave you. So 5.2 worksheet is your assignment. Just do it on another sheet of paper, please.